When we were practicing completing the square, we were just trying to figure out the number that allowed you to create the perfect square. So what if instead of not having anything out here, I already have a number? So it isn't any more difficult. What we're going to do is just set it up to look exactly the same. So what I'm going to do is keep the parts with x's, and I'm just going to kind of shove that little -4 out to the side. So inside the parentheses, I'm doing exactly what I did before. I'm saying what is half of 6? 3. What is 3 squared? 9. Okay, but I can't change a mathematical statement. If I want it to remain exactly the same as what it was, if I put 9 in, don't I have to take 9 back out? Right? This is just like saying if I had 5 and I added 9, but I subtracted 9 again, don't I still have the original 5 that I started with? Well, that's what we did. And then I'm going to rewrite it and say x plus 3 squared minus 13. So remember, and hope everybody is seeing this 3, when I would multiply this out, so if I was doing x plus 3, when I do the outside inside with FOIL, I'm going to get 6x. When I do the last, I'm going to get this 9. Okay? So take a minute and try both of these. So you may want to pause the video, try these, and then I will show you what you get. So again, x squared minus 14x, the parts with the x stay in, and put the number out to the side. I'm going to take half of the -14, so -7, square it, and I get 49. But if I put 49 in, I have to take 49 back out. And so the result is x minus 7 squared minus 46. Over here, keeping the x parts inside the parentheses, putting the -30 on the outside. Whoops, the x parts. Taking half of the -18, so -9, squaring it, I'm going to get 81. If I put 81 in, I got to take 81 back out. So I have x minus 9 squared minus 111. Okay, so what about this? We have done none that had a leading coefficient other than 1. Everything else had a leading coefficient that was 1. So again, all we're going to do is fix it to make it look like the ones we started with in the beginning. I'm just going to factor that 3 out, leaving x squared plus 8x. And I only am taking it out of this group, the group with the x's. This 5 is still just going out here to the side. Okay, then I'm going to do the exact same thing. I'm going to take half of this. Half of 8 is 4. 4 squared is 16. Okay, so here is the only part we have to make sure we understand on this. I haven't just put 16 in. I've put 16 times 3 in. So what I've put in was 48. So what I have to take back out is 48. And so I'm going to have 3 times x plus 4 squared minus 43. So two things to remember. Factor out whatever the leading coefficient is from the two x terms. When you put it back in, you have to remember that there is a multiplier out front. So try these two. Maybe pause the video, try these two, and then I will show you the solution. Okay, so here we go. I'm going to take out the 2, leaving x squared minus 3x. Put the plus 1 outside. Half of negative 3 is negative 1.5. 1.5 squared is 2.25. Okay, and I haven't just put in 2.25, I've put in 2.25 times 2, so I've put in 4.5, so I take out 4.5. So my vertex form, after completing the square, is x minus 1.5 squared minus 3.5. Okay. Next one, we're going to take out, we're going to take out the 3. So we're leaving x squared plus 5x. I'm going to put the 10 out to the side. Half of 5, 2.5. 2.5 squared, 6.25. Okay, I didn't just put in 6.25, I put in 6.25 times 3. So I'm going to have to subtract out 18.75. So when I rewrite this, I've got 3 times x plus 2.5 squared minus 8.75. Okay, so again, now we know, why do we want to complete the square? It gets us from standard to vertex. Okay, and why would we want to go to vertex form? Well, we want to know the vertex, which is good in math problems because it will tell us the max and the min. We're going to see how that gets applied to application problems next time.